Hello and welcome to our discussion on inventory management and material management. Now, in last few lectures, we have talked about various techniques of inventory management, various models of inventory, like we had purchase model, we had manufacturing model. In purchase also we had shortage with shortage and without shortage. In manufacturing also we had with shortage and without shortage. And in previous lectures, we solved certain numericals based on purchase model with shortage, without shortage, manufacturing model with shortage and without shortage. Today we'll talk about quantity discounts, the quantity discount models of inventory management. Quantity discount. Now, what is quantity discount? Quantity discount is a discount that the supplier passes on to us if we buy larger quantities. Suppose we are ready to buy 5 units. Suppose we are ready to buy these 5 pens and each pen costs me 40 rupees. Now the supplier says that if you buy a pack of 10 pens, it will cost you 35 rupees only. So when I am buying 5 pens, it is costing me at rate of 40, that is 200 rupees. Now he says that buy a packet of 10 pens. If I do so, it will cost me only 35 rupees, that is a total of 350. Now what is happening over here? My requirement is 5 pens and it can be fulfilled in 200 rupees. But the supplier is passing on to me a benefit for buying larger quantity. And that benefit is these 10 pens would have costed me 400 rupees, but now they are only costing me 350 rupees. So in the complete scenario, there is a benefit of 50 rupees. So the supplier is enticing me into buying more quantity. Now what is the disadvantage of buying more? The disadvantage of buying more is, what is the advantage of buying more? Advantage is that ordering cost goes down. The advantage of buying more pens is that ordering cost goes down. I need 5 pens a month. Next month I would have gone to the shop or gone to the retailer or gone to the supplier and bought 5 pens again. Now this ordering cost, the cost of visiting the supplier, the cost of waiting over there for the packaging, the cost of coming back, all this cost is ordering cost. Now if I buy 10 pens today itself, I will be saving all this cost that I might have incurred on 1st of next month. So this is an advantage of buying more quantities. But then there is a disadvantage of buying more quantities. What is that disadvantage? That disadvantage is that carrying cost goes up. If you buy more, you have to store more. If you have to store more, you need larger godowns, you need more electricity, you need more air conditioning, you need more refrigeration, more cooling. So in buying larger quantities, there is an advantage that the ordering cost comes down, but there is a disadvantage that the carrying cost goes up. Now what we need to check is, we need to check between these two costs, that what is the difference between these two. Suppose my ordering cost, carrying cost is going up by, let us say 70 rupees, and the ordering cost is coming down by, let's say 10 rupees. So what is happening in this deal? It is going up by 70, it is coming down by 10 rupees. The net result is plus 60. Understand? Suppose the ordering cost is coming down by 10 rupees, the carrying cost is going up by 70 rupees, the net result for me would be 60 rupees. Now, if this saving is more than 60 rupees, then I will go for quantity discount. Now, suppose if I go for this quantity discount, I will be saving 50 rupees. Save 50 rupees, still my net scenario is plus 10. So I made a study, I checked what is my ordering cost, what is my carrying cost, how much will be the net saving in this deal. And that net saving is not exactly a net saving, that is an additional expense of 10 rupees. Now let us see another case. 30 rupees, 70 rupees. Net expense, I am saving 30 rupees. I am paying more 70 rupees. I am saving 30 rupees. This was first case. Now in second case, I am saving 30 rupees. I am paying more 70 rupees. So the net scenario is 40 rupees. In this deal, I will be saving 50 rupees. Why 50 rupees? Because 5 tens cost me 200 rupees. So 10 pens would have cost me 400 rupees. But in quantity discount, they are costing me only 50 rupees. So I am saving 50 rupees. So in spite of this arrangement between ordering cost and carrying cost, I will be saving something. I will be saving 50 rupees and net scenario would be 10 rupees. So if my ordering cost and carrying costs are tied in such a way that my net result is increase in cost, I will not be taking this quantity discount. I will be ignoring the quantity discount. I will be saying to my supplier that no, I will be buying in lots of 5 only. I won't go for lots of 10. But if the scenario is something like this, where ordering costs are very high, in such case, what we will do is, I will actually be saving 10 rupees in this complete deal. So in such a case, quantity discounts are a big welcome. So this is the idea behind quantity discounts, that the supplier gives you some discount and then you check against your own costs. If you are ultimately ending up in a profit situation, cost saving, you definitely go for quantity discounts. Otherwise, we reject the quantity discounts. So this is the idea behind quantity discounts. This is the idea behind the concept of quantity discounts. Now we'll take a question and try to understand how it plays in the numericals, how it plays in the real world. So we'll take a very basic question where we have the information like this. So the supplier suggests that if you buy anything under 1200, suppose I buy 1100 units, they'll cost me 10 rupees per unit, price per unit you can say. If you buy anything under 1200, it may be 1150, it may be 1190, it may be 1199. If it is under 1200, it will cost you 10 rupees per unit. If you order anything from 1200 to under 2000, that is 1990, 1999, anything ranging from 1200 to 1999, if your order size is such, it will cost you only 9 rupees. And if you order anything above 2000, 2000 or more, 2000, 2500, 2700, 3000, 7000, 8000, 11000, whatever figure, anything above 2000 or above, it will cost us 8 rupees. This is the proposal forwarded to me from my supplier. Now the other parameters are such that annual demand for an item is 4800 units. A is 4800 units. Ordering cost is rupees 500 per order. Ordering cost is rupees 500 per order. Then we have inventory carrying cost, 24% of purchase price. Carrying cost is 24% of purchase price per unit per year. And then the price breaks are as given here. We can see what quantity you will be ordering. Accordingly, you will be facing a cost, price, expense. And then it is find the optimal order size. If the order cost is changed to 300, find the optimal order size. So the two questions are find optimal order size. Optimal order size. And second thing is if ordering cost is changed to 300 per order, find optimal order size. So this is the scenario we have. Fine. We have A, O and C as we used to have in EOQ. But this time there used to be a purchase price. If you remember, in one case the purchase price was 50 rupees and the carrying cost was 20% of 50 rupees. So we made use of 20% of 50 rupees. But this time the purchase price is changing. It could be 10 rupees, it could be 9 rupees, it could be 8 rupees depending on what amount of quantity you are ordering. So our purchase price will be varying and hence our carrying cost will be varying. So this is the idea which is different to this. Now let us go ahead and solve it. Let us go ahead and solve it. How do we solve these kind of questions? Now, being human, being a businessman, ideally I would prefer the lowest possible cost. Being human, I expect to get the lowest possible cost. So let me find out EOQ using the lowest possible cost, lowest possible price per unit, and let us see what happens. So I'll find out EOQ. EOQ using 2AO upon C. 2A is 4800, ordering cost is 500, and C is 24% of purchase price per unit per year. 24% of purchase price per unit per year. Now I want that my supplier should supply me for the supplies at 8 rupees. So if he is supplying at 8 rupees, the carrying cost becomes 24% of 8 rupees, which is 1.92. In this case, we get 1.92, and the final EOQ comes out as 2 multiplied by 4800 multiplied by 500 divided by 1.92, 1581.13. 1581.13. Now, if I make use of price per unit as 8 rupees, my EOQ comes out at 1581. Now, if you are ordering 1581 units, will the supplier supply you at 8 rupees? No. 1581 is in this slot. In this slab. 1200 to 2000. 1581 lies in this slot. So, the price applicable would be 9 rupees. So, I had a wishful thinking that I'll order at rate of 8 rupees. I prepared my order size of 1581 and I placed the order. But the supplier says that at 1581 I will not be charging you at 8, rather I will be charging you at 9. So this is the catch. I had a wishful thinking that the supplier will supply me at 8 rupees, but he says that the 1581 slot is 9 rupees. So what I will do is, I will revise my estimate. This is a rejection. This is wrong. This won't work out because this planning is according to 8 rupees. 24% of 8 rupees is 1.92. So this is gone. Now what I'll try is, I'll try EOQ for 9 rupees. Let this be EOQ 1, let this be EOQ 2. I tried EOQ first time, it failed. Let me try EOQ again. 2, A is 4800, O is 500. C would be 24% of purchase price. This time I am assuming the purchase price to be 9 rupees. So 9 it becomes 2.16, giving me a final value of 4800, 500 divided by 2.16, we get 1490.71. We get 1490.71 units. Now see, last time I tried that what if the supplier supplies me at 8 rupees. In that case, EOQ was 1581. I placed an order of 1581. The supplier said, no, 1581 falls in the 9 rupee category. So I'll charge you at 9 rupees. Okay, no issues. I came down to 9 rupee category. EOQ for 9 rupees was 1490. Now I place another order of 1490 units at assuming that the price will be 9 rupees. And the supplier also says that yes, 1490 falls in this 9 rupee category and this is a good deal. This is a good deal for both of us. I am getting my EOQ quantity. The supplier is able to serve me in 9 rupees. So this is definitely an accepted EOQ value. But the important thing is find the optimal order size. This time we need not find EOQ only. Rather, we'll try to find out optimal order size. So this is first phase. These kind of questions, quantity discount questions, are solved in 2 phases. The first phase is step 1. Find valid EOQ quantity. Find valid EOQ quantity, economic order quantity. This is valid economic order quantity. Now we start with our second stage. Second stage is, step second is compare inventory management costs. Now I'll try to compare my inventory management costs. So this is my first stage where I have found out a valid EOQ, valid economic order quantity. Next is, let us try to find out cost. Now let us understand the concept of cost. Total cost is direct cost plus indirect cost. This direct cost is basically purchase price, and this indirect is split into 2. We have ordering cost and carrying cost. Fine. So now compare inventory management costs. So this is my total inventory management cost, which consists of direct and indirect. Direct is purchase price. Whatever units you are purchasing, you will be purchasing 4800 units in complete year. This is the annual demand. So that will be purchase price. Then indirect cost would be ordering cost plus carrying cost. Now what are the formula? What could be the formula for these? The purchase price would be annual demand multiplied by purchase price. 4800 units down the line I will be purchasing. They may be in lots of 1581, they may be in lots of 1490, they may be in lots of 1000, they may be in lots of 200, but ultimately in the complete year I need to purchase 4800 units. I need to buy 4800 units so that I can sell 4800 units. The annual demand is expected to be 4800 units, so I need to arrange for those in whatever lot sizes, but definitely I need to arrange for these 4800 units. So ultimately I will be arranging these 4800 units, and at what purchase price depends on my price slab. If I am ordering 200 units, it will cost me 10 rupees. If I am purchasing in lots of 1500 units, it might cost me 9 rupees. If I am purchasing in lots of 2500 units, it might cost me 8 rupees. So that depends. Purchase price would be either 10, 9, 8 depending on what quantity you are ordering in lot. What is the lot size? Ultimately you will be ordering 4800 units. Fine. So this is my total purchase price in the year. What is ordering cost? Ordering cost put in simply is number of orders multiplied by per order ordering cost. Number of orders multiplied by per order ordering cost. Now, if you remember, what are the number of orders? A divided by whatever is your order size. I'm not putting it as EOQ because this time we'll be trying to find out optimal order size. It could be EOQ, but it could be something else also. So instead of calling it EOQ, let us call it order size. Let us call it Q. It can be EOQ, it can be anything. It can be 2000, it can be 1200, it can be something else. So we have purchase price as this. We have ordering cost, number of orders is A multiplied by Q, and per order ordering cost is O. Per order ordering cost is O. So this becomes my ordering cost formula. And then last one is carrying cost. Carrying cost, we have checked in earlier videos. What will be the carrying cost? Number of units carried multiplied by per unit multiplied by per unit carrying cost. How many units do I carry? I carry half of my order size. This we have checked in previous lectures when we actually derived EOQ. In that time we saw that number of units carried is half of the order size. If you are ordering EOQ, then it will be half of EOQ. If you are ordering something else like 2000 or 1200, it will be half of 1200 or 2000. So it is half of number of units carried is half of the order size multiplied by carrying cost is C. So these are the three costs. Now what I need to check is, when is this complete cost minimum? When is this complete cost at minimum level? It is expected that EOQ will give me the minimum level. But this time the catch is there are discounts to be had. If there were no discounts, definitely EOQ would have given me best result. But because there are discounts, let me explore what happens if I try to use these discounts. So what we'll do is, we'll prepare a table for this. Because in tabular form, it is easy for us to manage, check, understand, है ना? So we'll prepare a simple table. What are the various headings in this table? We have quantity, purchase price, and then there is ordering cost, and finally we have carrying cost and total cost. So we'll try to tabulate our results so that they are easy to interpret. Now, first shot is at EOQ, because my understanding suggests that EOQ is best quantity to be ordered. So what is the EOQ quantity? 1490.71. 1490.71. Suppose I go ahead with 1490.71. What is total cost of my inventory management? Now, If we go ahead with 1490.71 units, what will be the purchase price? I'll be purchasing 4800 units and the per unit price at 1490. 1490 per unit price is 9 rupees. So what will this value be? This value will be 4800 units ultimately purchased at what rate? At 9 rupees per year, per unit, giving me 4800 multiplied by 9, that is 43200. This will be 43200. Next is ordering cost. What is ordering cost? A upon Q multiplied by O. A is 4800, ultimately you need 4800 units. Q is the order size. Order size we are going ahead with 1490.71 multiplied by ordering cost. Ordering cost is given as 500 rupees. So what will be my ordering cost? It will be 4800 multiplied by 500 divided by 1490.71, giving me 1609.97. 1609.97. 1609.97. And then what about carrying cost? It is half of quantity ordered multiplied by carrying cost. Ordered quantity this time is 1490.71, half multiplied by carrying cost. What is the carrying cost in this case? When the applicable rate is 9 rupees, carrying cost becomes 2.16. 2.16. So we get 1490.71 divided by 2 multiplied by 2.16, giving me 1609.97 again. 1609.97. Now you see the ordering cost and carrying cost is same because the quantity is EOQ. This is the idea behind EOQ. EOQ is that quantity where ordering cost and carrying cost are equal to each other. We can see that they are equal. And if we try to find out total cost, it would be 46419.9. 46419.9. This is 43,000. This is roughly 3,000. Okay, 46419. Now, if I go ahead with EOQ, this will be the total cost that I'll incur in the year, because I'll be buying these 4800 units in lots of 1490 and I'll be making a payment at rate of 9 rupees. So, in the complete year, I'll be buying 4800 units at rate of 9 rupees. Then ordering cost would be this and carrying cost would be this in the complete year. So, this becomes my total cost. Now the business mind steps in and it suggests that let us try and explore what happens at 8 rupees. When can you get 8 rupees? If you place an order of 2000. So, I ask my team, let us explore what happens if I place an order of 2000. Now, I'll make use of some other color so that we can compare. If I place an order for 2000 units, 4800, but if you are placing an order of 2000 units, it will cost you at rate of 8 rupees. So, it becomes 4800 multiplied by 8, 38400. It becomes 38400. 38400. Fine. And then next one would be 4800 units ordering cost. A is 4800, but this time order size is not 1490. This time order size is 2000 because I am trying to get a purchase price of 8 rupees. When can I get a purchase price of 8 rupees? If I am placing an order of 2000. And ordering cost would be 500 again. So 500, it will become 4, it will become 1200. So we get this as 1200. Fine. 1200. And last one would be carrying cost, half of order size. Order size is this time 2000, half of that multiplied by carrying cost. Carrying cost would be 24% of 8 rupees. 24% of 8 rupees would be 1.92. So this becomes 1000, this becomes 1920. 1920. So what do we get? 19 and 12 would be 3120 plus 3120. It is 41520. 41520. 3000 roughly. Yes, it is 41520. So, should we go ahead with economic order quantity or should I go ahead with this larger amount, 2000? See, EOQ suggests that I should order 1490 units, but I am ordering 2000 units instead of EOQ. Why? Because at EOQ it will cost me 9 rupees per unit. At 2000 it is costing me only 8 rupees per unit. If we have an analysis of this table, what is this table suggesting? That yes, carrying cost has gone up, but ordering cost has come down. Carrying cost has gone up by roughly 300. This is just an analysis. This is not a part of question that you need to represent. Just we are trying to understand. The carrying cost has roughly come down by 400. The ordering cost has roughly gone up by 300. But there is a huge amount of saving over here. It is almost 5000 rupees worth of saving. Due to this drop in purchase price, I am saving 5000 rupees. So as far as carrying cost and ordering cost are concerned, they are only making a difference of some 100 rupees or so. But this is the major saving. From 46,000, my total cost has come down to 41,000. 5,000 rupees worth of saving. And why is this 5,000 coming? Because you are buying almost 5,000 rupees at 1 rupee cheaper. So there is the huge saving. So what will be my optimal order size? Economic order size is 1490. But what is my optimal order size? My optimal order size will be, therefore, optimal order size is 2000 units. Whenever you place an order, go ahead and place an order of 2000 units. By doing so, your complete inventory management, annual inventory management cost will come down from 46,000 to 41,000 rupees. This is the idea of quantity discount models of inventory management. So, up till this point, we have seen purchase models and manufacturing models. Today, we have talked about quantity discount models. And these models are solved in two steps. First step is find a valid EOQ quantity. What do we mean by valid EOQ? Valid EOQ is, let us start with the cheapest EOQ. If we get a valid quantity, that is, if this quantity falls in this price slab, then it is a valid. But our quantity was falling in 1581, it was falling in 9 rupees slab. So I went for 9 rupees. If it were falling in 10 rupees slab, I would have gone for 10. So this gives you a starting point, that which price you should explore first. If this falls in 9, I'll check for 9. Yes, if this falls in 10, so I'll check for 10, I'll get a valid EOQ. And in this table, what I'll do is, I'll find a valid EOQ cost, total cost. Then I'll find a 1200 rupees cost. In which case, the units will be 1200 and all these prices will be calculated according to 1200. And finally, I'll find it according to 2000 at a rate of, for 2000 units at rate of 8. So this is how we can proceed. First step is find a valid EOQ, and wherever that valid EOQ comes, beyond that point, check your prices. Now my valid EOQ was coming in this, so I only checked 2000. If your valid EOQ sometimes comes in first slot, you should check for 1200 units also at rate of 9, 2000 units also at rate of 8. How? In this fashion. Fine. So this was it for our quantity discount model. I'll put up some more questions in the Telegram channel. The link is available in the description box. You can go there, you can get these practice questions. You can practice these questions. We can tally these questions. If there are some issues with your solution, you can leave comment under this video. So this is it for our today's discussion. Until we meet next time, do take care. Thanks for watching. Bye-bye.